Hello guys, my name is Desmond and I welcome you to my lesson for today. Ladies and gentlemen, I assume at this point in time everyone knows that a day without learning something new, it's a day wasted. By so saying, ladies and gentlemen, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Okay, so guys, for today's lesson we'll be looking at vertical projectile motion. Okay, so obviously, ladies and gentlemen, I've done a complete lesson where I teach you all that you need to know in relation to this chapter. So ladies and gentlemen, if you do check out the lessons that I've done on my website, www.solvingexampapers.co.za, under physical sciences, ladies and gentlemen, for grade 12, you should be able to find all the lessons that I've done. If you watch all of those lessons, you'll be able to answer all of these questions. And most importantly, ladies and gentlemen, even if you haven't watched those lessons, you can still rely on the information that they taught you in class. It should be enough for you to be able to understand today's lesson. And most importantly, ladies and gentlemen, please do try to work out this question after watching this lesson, so that you try to check if you'll also apply the same approach. Okay, one thing for sure, towards the end of your semester or whatever that you call it, ladies and gentlemen, just before you write your exams, be it your mid-year exams or your final exams, I'm going to make sure that I do this lesson where I solve all these questions. Okay, otherwise, in case if you drop a comment where you request for this question to be solved, then I will do it upon your request. Okay, but otherwise, if you understand all that I'll be saying in this lesson, ladies and gentlemen, you are more than welcome to to work it out and drop me a WhatsApp text where you confirm your final answers. Okay, so ladies and gentlemen, what I'm going to do now is just to quickly read through the given statement. Okay, so ladies and gentlemen, it's very, very much important that at all times you read to understand the given statement. Okay, remember guys, we're doing question 3. Okay, they are saying start on a new page. Very, very much important, ladies and gentlemen, not forgetting that this was a November 2014 exam paper. Okay, physical sciences paper 1. Very, very much important, ladies and gentlemen. So now, in most cases, you are advised to start each question on a new paper. Okay, it makes it very much easy for us to easily mark your answer sheet. Ladies and gentlemen, you're given a statement. I'll just quickly read through the given statement. A ball is referred to as ball A. Okay, a ball A is thrown vertically upwards from a height referred to as h with a speed of 15 meters per second. At the same time, or at the same instance, a second identical ball B is dropped from the same height as ball A, as shown in the diagram below. Both balls undergo free fall and eventually hit the ground. Ladies and gentlemen, that was the given statement. Very, very much important that you fully understand what's going on over there, ladies and gentlemen. So as you can see over there, ladies and gentlemen, we've got ball A, and again we've got ball B. So ladies and gentlemen, it's very, very much important that you are able to identify both balls. Okay, what happens to ball A, ladies and gentlemen? So obviously they say ball A is thrown vertically upwards from a height. Okay, which height are they talking about, ladies and gentlemen? This is the height that they are talking about. So obviously this ball A is thrown vertically upwards, ladies and gentlemen. Very, very much important. Okay, and most importantly, that ball is thrown at a speed of 15 meters per second, which is an indication, ladies and gentlemen, that it's V initial. Okay, the initial velocity of ball A is 15 meters per second. Okay, and again they say at the same instant, very, very much important, ladies and gentlemen, at the same instant, a second identical ball B is dropped from the same height as ball A, as shown in the diagram below. Ladies and gentlemen, from that very same height, okay, which height, ladies and gentlemen? From that very same height, okay, ladies and gentlemen, ball B is dropped, okay, is dropped from the same height as ball ball A. Okay, so ladies and gentlemen, the word dropped, very, very much important, ladies and gentlemen. Remember, guys, when a ball is dropped, okay, it actually indicates that its V initial, ladies and gentlemen, it's equals to 0 meters per second. Okay, very, very much important, ladies and gentlemen, because it is dropped. Okay, unlike in this case, ladies and gentlemen, where they said ball A is thrown vertically upwards. Okay, it's a different story, ladies and gentlemen. When you throw an object vertically upwards, it obviously needs a certain speed. Okay, so that becomes the initial velocity of ball A when it's thrown vertically upwards. But in this case, with regards to ball B, ladies and gentlemen, what happens in that case, it is dropped. Very, very much important, ladies and gentlemen, it is dropped, most importantly, from the same height as ball A. Okay, now the statement continues, as you can see over there, ladies and gentlemen. They're saying both balls undergo free fall and eventually hit the ground. Very, very much important, ladies and gentlemen. So guys, let me just explain in addition to what I've just explained, okay, just so that we're on the same page as we go through those questions. So ladies and gentlemen, remember, guys, as ball A goes up, it obviously experience an acceleration in the opposite direction. Okay, an acceleration of 9.8 meters per second squared. Okay, very, very much important, ladies and gentlemen. Obviously, that means as this ball A, ladies and gentlemen, as this ball A, it's moving upwards, its velocity keeps on decreasing until it reaches a maximum height. This will be the turning point, ladies and gentlemen, which is indicated over there. Okay, that is the turning point of ball A. Ladies and gentlemen, what information do we know at the turning point of an object which was thrown vertically upwards? We know very well that, obviously, ladies and gentlemen, if we assume upwards to be positive, most importantly, then the gravitational acceleration or acceleration as a result of gravity, it's negative 9.8. Why? Because it's acting in the downwards direction, and at all times, gravitational acceleration, ladies and gentlemen, it's always acting in the downwards direction. Okay, it's trying to pull all objects towards the center of the earth. So ladies and gentlemen, going back to that point where I asked a question to say, what is it that we know at a point where an object was thrown vertically upwards? What happens at its maximum height? Ladies and gentlemen, we know that that's where it has reached its final velocity from its initial velocity where it was projected vertically upwards. Okay, we know very well that velocity final, it's equals to 0 meters per second. Okay, very, very much important, ladies and gentlemen. Please do make sure that you fully understand this information that I'm trying to explain to you guys. So I'll just remove all of that information. So ladies and gentlemen, remember guys, remember, most importantly, the time taken for this object to reach its maximum height. Okay, the time it took for that object A to reach its maximum height. Let's say this is time 1. Okay, obviously it will reach its maximum height and it will obviously change the direction and now fall downwards from its maximum height. Very, very much important, ladies and gentlemen. So now the time it takes for it to cover that distance, ladies and gentlemen, from its maximum height to where it was initially projected vertically upwards, ladies and gentlemen, which we can refer to that as time 2. It will be the same time. So ladies and gentlemen, in short, what I'm saying is, if it takes 4 seconds, okay, for object A or ball A to reach its maximum height, it will still take 4 seconds, ladies and gentlemen, for it to reach that same level from which or from where it was projected or thrown vertically upwards. So ladies and gentlemen, let me not go deep into that information because I explain in detail in those lessons that I've done, ladies and gentlemen. Hence, I encourage you to check out all of those lessons. Okay, so guys, I'm not really sure if there's something that I might need to add to this information. Okay, so let me just try to add this information. So ladies and gentlemen, with regards to object B, okay, obviously its initial velocity from that point, it's equals to 0. Okay, very, very much important, ladies and gentlemen. So what happens as this object moves or falls downwards? Ladies and gentlemen, its velocity keeps on increasing. Okay, that's what happens to its velocity until it hits the ground, as indicated over there, ladies and gentlemen, where they say both balls undergo free fall and eventually hit the ground. Okay, so ladies and gentlemen, what happens when it hits the ground is that, that is its final velocity, okay, which is unknown at this stage. So ladies and gentlemen, it means when that object B hit, when it hits the ground, that's where we can refer to that point as its final velocity. And obviously, ladies and gentlemen, since its velocity increases as it falls down, that means this is where it reaches the ground at its maximum velocity. Okay, because obviously it increases its velocity as it falls downwards. Ladies and gentlemen, the other thing that I need to emphasize is the fact that if you assume upwards as positive, ladies and gentlemen, that means the movement downwards is negative. Okay, so obviously it means we're going to have a positive V and a negative V. Okay, and again we're going to have a negative G, ladies and gentlemen. Okay, that's if we assume upward to be positive. And again, ladies and gentlemen, the displacement, okay, the displacement, what am I talking about in terms of displacement, ladies and gentlemen? So obviously, as this object A, ladies and gentlemen, obviously as this object A or ball A, it's moving upwards, ladies and gentlemen, it is covering a positive change in Y. Okay, why? Because a displacement, ladies and gentlemen, is what we call a vector quantity. Okay, just like the distance, it's referred to as a scalar quantity. What does it mean when it's a scalar quantity, ladies and gentlemen? It means it only has a magnitude, it only has a value, ladies and gentlemen. But a vector quantity, ladies and gentlemen, it has both the magnitude, and the direction. Okay, that's the difference between a scalar quantity and a vector quantity. Ladies and gentlemen, remember I've done a lesson where I explain all of this in detail. Okay, so ladies and gentlemen, with that being said, it means a object B or ball B will be covering a negative displacement, ladies and gentlemen. So that sign, guys, that sign, it only refers to the direction. Okay, so that means when you do calculations and you find a negative displacement, it means is the displacement covered in the downwards direction. If you find a positive answer, ladies and gentlemen, it means is the displacement covered in the upwards direction. Okay, so guys, without any waste of time, let's try to now discuss the questions. Okay, I assume you fully understood that explanation. So ladies and gentlemen, our very first question, which says explain the term free fall. Okay, ladies and gentlemen, the question says explain the term free fall. Guys, at all times, or let me say in most cases, each and every question has got a cream. Okay, so ladies and gentlemen, I'm hoping to teach you on how to identify the cream in each and every question. Okay, so ladies and gentlemen, what is the cream of that question? Guys, the cream of a question is that word or those words when removed from the question, the question will remain senseless or it won't make any sense. Ladies and gentlemen, it means you won't be able to understand exactly what the question wants you to solve or explain, define, or answer. Okay, so ladies and gentlemen, for example, if we remove that word explain, then we remain with the term free fall. Okay, so obviously, ladies and gentlemen, you need that word, because if a question just says the term free fall, you don't know exactly what the question wants you to do. Okay, so otherwise, ladies and gentlemen, if you remove that word there, what do you remain with? You remain with explain the term free fall. Okay, so it still makes sense. So that means that word there, it's not the cream. Okay, so ladies and gentlemen, again, that word term, if we remove that word, we remain with explain free fall. Can you see? You can still answer that question because it makes sense. So that means that word term, it's not the cream of the question. Okay, so obviously, guys, in most cases, free fall is just one word. Okay, so if you remove free fall, you remain with explain the term. Can you see, ladies and gentlemen? If you remove free fall, then explain the term alone, it doesn't make any sense. So ladies and gentlemen, by so saying, I'm simply trying to indicate to you that these two words, explain and free fall, are the cream of the question. Okay, why is it important for you to be able to identify the cream of the question? Is because that's where the instruction comes from, ladies and gentlemen. That's how you should present your answer. Okay, so ladies and gentlemen, it simply means you need to give an explanation of the term free fall. So for you to get maximum marks, ladies and gentlemen, that's if you explain what is meant by free fall. Okay, by so doing, you will score yourself 2 marks. Okay, so guys, at all times in my upcoming lessons, I'll be teaching you on how to identify the cream of the question. Okay, so in this case, I had to go deep so that when I use the same approach in all of these questions, you don't get surprised. Okay, so I'll just quickly identify the cream of the question. And obviously I won't be going word to word. Okay, so now, ladies and gentlemen, let's move to the next question 3.2. okay, first thing to realize, that question is allocated 4 marks, which means you might need to perform some calculations or otherwise apply a bit of your understanding. Okay, so ladies and gentlemen, without any waste of time, let's try to have a look at that question. So it says, calculate the time it takes for ball A to return to its starting point. Very, very much important, ladies and gentlemen. What is the cream of that question? So let me just quickly try to to identify the cream of that question. So it's calculate the time. So let me see, calculate the time. This is a very important instruction. It takes for the ball, which is ball A, to return to its starting point. Okay, so ladies and gentlemen, it seems like most of the words over there are very much important, but the cream of this question, ladies and gentlemen, the main word is time. Okay, so that means in the end, ladies and gentlemen, you should say time it's equals to whatever seconds. Very, very much important, ladies and gentlemen. Do not give your final answer as anything else other than time. Okay, we don't want meters per second, we don't want meters per square second, we don't want meters, we don't want kilometers. Ladies and gentlemen, we do not want anything other than time. Very, very much important, ladies and gentlemen. So that means the cream of that question, ladies and gentlemen, it's time. Okay, so you need all this other information in order to tell or to know which time are they talking about. Okay, so ladies and gentlemen, they are talking about the time it takes for ball A to return to its starting point. Very, very much important, ladies and gentlemen, to return. What does it mean? So ladies and gentlemen, they want to know the time it takes for that ball A, okay, to return to that same point. So that means is the time it takes for it to go up and again to return to that same point. Very, very much important, ladies and gentlemen. And remember, from when I started this lesson, I indicated to you that the time it takes for that object to reach its maximum height, it should be the same time it takes for it to return to that same level. Okay, so obviously, guys, you can use the formula to calculate the time it takes for it to reach its maximum height. Okay, then as soon as you find that time, that's when you can multiply that time by 2. Let's assume it takes 1.53 seconds for it to reach that maximum height. Okay, so what I'm saying, ladies and gentlemen, because it takes the same time for it to go up and down, then it means it's 2 times 1.53, which is whatever that you get when you punch all of this on your calculator, ladies and gentlemen. Just say time is equals to whatever in seconds. Okay, so that is exactly what the question wants you to calculate. Okay, do not give anything other than time. And ladies and gentlemen, what I like about physical sciences is that they normally give you a mark for just copying the formula from the formula sheet. Okay, they give you some marks for correct substitution, ladies and gentlemen. If you substitute correctly based on the information that you've got, you score some marks. And lastly, you score a mark for your final answer with the correct SI units. Time is measured in seconds in physical sciences. Okay, so that's how you most likely to score your full 4 marks. Very, very much important, ladies and gentlemen. Remember, guys, you've got initial velocity, the final velocity, And again, ladies and gentlemen, taking into consideration the direction, you already know the value of G. Okay, so in most cases, you just need 3 quantities for you to calculate the fourth quantity. Okay, so guys, there are so many ways to kill a cat. Okay, so that's not the only way in which you can solve this problem. There are multiple ways, but for you, in order to be able to apply all the possible ways to solve these questions, ladies and gentlemen, please do check out my lessons. That's where I teach all the methods. Okay, you will be able to answer this type of questions in different ways. Okay, so now let's remove everything and move on to the next question. Ladies and gentlemen, let's now move to question 3.3. okay, the question says calculate the distance between ball A and ball B when ball A is at its maximum height. Ladies and gentlemen, this question, it's allocated 7 marks, okay, which is an indication that you need to apply your mind, ladies and gentlemen. Very, very much important. Please do make sure that you take your time to read the question and understand exactly what the question wants you to do. Okay, so ladies and gentlemen, what does the question wants you to do? They want you to calculate. Very, very much important, ladies and gentlemen. So that means you need to perform some calculations. What are you calculating? You calculate the distance. Very, very much important, ladies and gentlemen. So that means your final answer, ladies and gentlemen, it should be in the unit meter, meters. If it's, obviously you've got 1 meter, you've got 1.1 meters or 1 point whatever meters, okay, but otherwise you can still have 0 point something meter. Ladies and gentlemen, very, very much important. The point that I'm trying to emphasize here is that the SI unit, ladies and gentlemen, the SI unit, it should be meters. Okay, we measure distance, displacement, whatever in meters when it comes to physical sciences. Ladies and gentlemen, taking into consideration the fact that distance is a scalar quantity, so that means it's just distance which is in meters, no need for direction. Okay, no need for positive or negative sign which refers to direction in physical sciences. Okay, so ladies and gentlemen, they want you to calculate the distance between ball A and ball B when, very, very much important, when ball A is at its maximum. Very, very much important, ladies and gentlemen, when ball A is at its maximum height. Okay, so guys, it seems like a distance is the cream of that question. Why am I saying that, ladies and gentlemen? Is because if you remove that word distance, you remain with calculate the between ball A and ball B when ball A is at its maximum height. Ladies and gentlemen, in that way you're not able to tell what exactly to calculate. Okay, it doesn't make sense. So that's why I'm saying, ladies and gentlemen, you need to identify that one word when removed from a sentence or a question, the question becomes senseless or it doesn't make sense. Ladies and gentlemen, I assume you now understand what is meant by the cream of the question. Okay, so guys, I'm going to give you guidance in terms of how to approach this type of a question, taking into account the fact that this question is allocated 7 marks. Very, very much important, ladies and gentlemen. So that means you will need to perform some calculations. Okay, so guys, remember, in this case, you're mostly interested in the distance. Okay, so obviously, guys, ladies and gentlemen, if you calculate the distance, if you calculate that distance, ladies and gentlemen, it could be your starting point. Remember, guys, obviously they indicated that when ball A is at its maximum height, they want to know the distance between ball A and ball B. Okay, let's say this is ball A at its maximum height over there. Okay, and now let's say this is ball B somewhere there. Okay, it's not really at that point, but I'm just assuming to say somewhere there. Okay, so what I want to explain, ladies and gentlemen, is that as ball A, it's moving upwards, at the same time ball B, it's also moving downwards. Okay, so can you see, ladies and gentlemen, as that ball A covers that height, which is when it reaches its maximum height, ladies and gentlemen, at the same time also a ball B, it's covering a certain distance. Okay, ladies and gentlemen, what the question wants you to calculate is that distance. Okay, very, very much important, ladies and gentlemen. Very, very much important that you fully understand what the question wants you to calculate. Okay, so it's more like they want you to calculate that distance, of which we can refer to as distance 1, and again that distance 2. Okay, then you can add both distances in order to find that total distance, ladies and gentlemen. I'm not really sure if it makes sense. Okay, so what is it that you know about ball A, ladies and gentlemen? Let's start with ball A. Okay, obviously we know at its maximum height, its V final, it's equals to 0. Okay, we also know that V initial, it's equals to 15 meters per second. Okay, and again we know it experiencing a negative g. Very, very much important, ladies and gentlemen. So now you can find a formula to calculate that displacement or distance, okay, as it moves upwards. And again, ladies and gentlemen, from the previous question, we calculated the time it took for that object to reach that maximum height. Okay, so ladies and gentlemen, what is the relationship between the relationship between object or ball A and that ball B? It's because, ladies and gentlemen, we can use the same time as that object reaches its maximum height, okay, to say at that time that object would have covered a certain height. Okay, so obviously it means there is a relationship between that object A and object B with reference to this question, ladies and gentlemen. Okay, remember they are saying calculate the distance between ball A and B when ball A is at its maximum height. Okay, how do we calculate that distance, ladies and gentlemen? How do we calculate that distance when ball A is at its maximum height? Obviously, guys, we will use that time it took for that object A to reach its maximum height. Okay, so guys, what information do we know about object B? Okay, very, very much important, ladies and gentlemen. Remember, you need only 3 quantities in order to calculate the 4th quantity. Okay, so in this case, what's the 4th quantity that we want to calculate? Obviously is that distance number 2. Okay, so ladies and gentlemen, I'm not referring to that distance, okay, but I'm referring to that distance number 2 where that distance is covered by object B. Remember, guys, that distance could be from there to there. Okay, it could be from that very same point to there. It could be from that very same point to wherever, ladies and gentlemen. We're not really sure in terms of the exact distance. We just know it's somewhere there. Okay, so for us to be able to calculate that distance number 2, ladies and gentlemen, we need 3 quantities. What do we know about object A? We know that its V initial, ladies and gentlemen, it's equals to 0. Why? Because they said it's being dropped. You remember, ladies and gentlemen, from that statement, object B is being dropped, which means its initial velocity is equals to 0. Okay, and again, ladies and gentlemen, very, very much important. Remember, guys, we know it's experiencing gravitational acceleration of 9.8. Okay, very, very much important, ladies and gentlemen. That's the second thing that we know about that object B. Okay, so now, because we're doing calculations of object B in relation to object A, we know, guys, the time it takes for object A to reach its maximum height. Okay, so we can use that same time, ladies and gentlemen. Let's say, for example, that time, I can't really remember of exactly what we assumed, but ladies and gentlemen, let's say that time is 3.06 seconds. Okay, so that means we will use this time, that initial velocity, and that g to calculate distance number 2, ladies and gentlemen. As soon as we are done with those distances, ladies, you can just say distance number 1, you add it with distance number 2, then you get your distance in meters, ladies and gentlemen. That's how you score your 7 marks. Okay, ladies and gentlemen, remember, this is just a guide in terms of how to approach, analyze, and interpret the given information, the diagram, and also the question. Okay, very, very much important, ladies and gentlemen, that you understand what I'm explaining to you guys. Otherwise, if you need to see how I solve this question, please do make sure to check out my lessons, ladies and gentlemen. You can just drop me a WhatsApp. I will refer you to a link which will directly take you to where I've solved this question. Okay, ladies and gentlemen, let's now move to question 4.3. Okay, so guys, obviously, question 4.3 says sketch a velocity time graph in the answer book for the motion of ball A from the time it is projected, until it hits the ground. What an interesting question, ladies and gentlemen. Just want to take this opportunity to explain to you that, ladies and gentlemen, they want you to sketch. Very, very much important. So, ladies and gentlemen, we don't want to see any calculations. Most importantly, no calculations, ladies and gentlemen. Do not calculate anything. Don't want any calculations, okay? But otherwise, sketch, okay? Very, very much important, ladies and gentlemen. Sketch a velocity time graph. So, ladies and gentlemen, you might need to be sketching something of a velocity in the units in brackets and time, ladies and gentlemen. This is a velocity time graph. Okay, that's what they want you to sketch. Okay, ladies and gentlemen, do not perform any calculations. Sketch a velocity time graph in the answer book for the motion of the ball A from the time it is projected until it hits the ground. What an interesting question, ladies and gentlemen. From that point where it is projected, ladies and gentlemen, it obviously goes up, reaches its maximum height, changes direction, goes down until it hits the ground. Very, very much important, ladies and gentlemen. So that means on your velocity time graph, ladies and gentlemen, they want you to show clearly the following, ladies and gentlemen. That's what they want you to show. So guys, someone is asking themselves, what is the cream of the question, ladies and gentlemen? It seems to be velocity time graph is the cream of that question, because if you remain with anything else, ladies and gentlemen, you're just aware that they want you to sketch, but you don't know exactly what they want you to sketch. Okay, so ladies and gentlemen, that's why I'm saying velocity time graph is the cream of that question, because you know you've got velocity versus time graph. Okay, Ladies and gentlemen, on my lessons, I explained all the types of graphs that they might want you to sketch. Okay, so if you check out all those lessons, you'll be able to learn all the type of graphs that they would request you to sketch under this chapter. Okay, so ladies and gentlemen, most importantly, they want you to clearly show the initial velocity. Okay, on that very same graph of velocity time. Okay, show clearly the initial velocity. Ladies and gentlemen, the time it takes to reach its maximum height. Okay, massively important, ladies and gentlemen. And again, the time it takes to return to its starting point. Okay, by so doing, ladies and gentlemen, you score yourself 4 marks. Okay, so ladies and gentlemen, please do make sure that when you sketch your graph, you show all of those things. Okay, so I'm just going to give you a hint, ladies and gentlemen. Obviously, it's your velocity there. Make sure you write the units. Okay, you score some marks for that. Ladies and gentlemen, obviously this is your time in seconds. Okay, by just doing this, ladies and gentlemen, you might find that you score yourself some marks. Okay, ladies and gentlemen, let's now show as per the instruction. Okay, show the initial velocity. Obviously, guys, if you assume upwards to be positive, you might have a graph similar to this. Okay, remember, guys, you show that initial velocity of that object. Okay, I think it was something 15 meters per second. Okay, obviously, ladies and gentlemen, obviously that object, as it goes up, ladies and gentlemen, it covers a certain time. You remember there was that time that we assumed for it to reach its maximum height. Okay, I'm not really sure of that time, but I think we assumed 1.5 what was it, 3, ladies and gentlemen. We assumed 1.53 seconds for that object to reach its maximum height. Okay, obviously, guys, obviously it means it will still take the same time, ladies and gentlemen, 1.53. remember there it's 1.53. it will still take the same time for it to reach that same level. Okay, very, very much important, ladies and gentlemen, that you apply your mind when you deal with this type of graphs. Most importantly, ladies and gentlemen, remember at that point, ladies and gentlemen, we write the correct value, which is 1.53 plus 1.53. it makes it a different number, which is 3.06. okay, let me just do a quick example so that you understand. Remember, guys, let's say we had time as 2 over there. Okay, then we know it still take the same time to reach that same level. You cannot say it's 2 there, ladies and gentlemen. It has to be 2. Okay, obviously the time continues. Okay, you cannot have 2 there and 2 there. So that's why I'm saying there it's 1.5, there it's not 1.5 but it's 3.05, which is 1.5 plus 1.5, it takes us to that. Okay, so ladies and gentlemen, I'm not sure if you fully understand that part. So it's more like by so doing, we have indicated the time it takes to reach its maximum height, because obviously, ladies and gentlemen, this is the first time this is that time it reaches its maximum height. Okay, and again that time it's where it returns to its starting point. Ladies and gentlemen, I assume we are still on the same page. Okay, so obviously, guys, right at that time, ladies and gentlemen, right at that time, that's where obviously its speed it's 15 meters per second, but obviously in the negative direction because it will be in the downwards direction. Very, very much important, ladies and gentlemen. Massively important. That's why sometimes you can just do that dotted line over there, ladies and gentlemen, to show that that time there, that's where its velocity is that. Okay, and again, ladies and gentlemen, you can now nicely and easily draw that graph to say it's a straight line graph, ladies and gentlemen, a straight line graph starting from that point because they said show the initial velocity. Okay, and again, ladies and gentlemen, on your graph it's very, very much important that it intercepts at that time, okay, where it reaches its maximum height. Okay, and again, ladies and gentlemen, it's very, very much important that you show that point where you've got that broken line or dotted line that shows that at that time that's where its velocity is 15. Okay, ladies and gentlemen, it's very, very much important that you extend that line. Why do you need to extend that line? It's because, ladies and gentlemen, the question said the motion of ball A from the time it is projected until it hits the ground. Okay, so it's more like, ladies and gentlemen, if you drew your graph, okay, you drew your graph and your line ended there, it's more like you've only drawn a graph of that object when from that point up to that point, which is where it's at that level. Okay, whereas the question says from that point all the way up to its maximum height until it goes down and hits the ground. Okay, very, very much important, ladies and gentlemen. I assume you fully understand that part. Okay, so guys, this brings us to the end of our lesson. Obviously, ladies and gentlemen, I think I've explained to you that you score your first mark by just indicating the correct axis. Obviously it's v, it's time with the units, ladies and gentlemen, with the units. Okay, you just score a mark. You're most likely to score 3 marks for showing all of this. Okay, so that's how you score your full 4 marks. Ladies and gentlemen, this brings us to the end of our lesson. Thank you very much for joining, ladies and gentlemen. I think it's about time we just put on a signature to say my name is Desmond, ladies and gentlemen, and I'm out.